Hello again, dear students. In this video, we will discuss how to find the cosine of the angle between two planes and how to find an equation of the plane. So, how to do this task? Firstly, we need to find coordinates of the normal vector to each plane using formula, which is this one. And secondly, we need to find cosine of the angle between two normal vectors. I think you know this formula already. So let's see how this formula looks like. So we have 3 points of the plane with coordinates. We just put these coordinates into this matrix. So just x1 is equal to something, x2 is equal to something, and so on. After this, we just transform this matrix in such way that it will be like x minus x1 multiplied by something plus y minus y1 multiplied by something minus, and here plus z minus z1 multiplied by something, and we equalize it to 0. And after this procedure, we will get an equation of the plane. A, B, C, and D are just numbers, some coefficients. And these coefficients, A, B, C, will be our coordinates of the normal vector to the plane, which we will use to find the angle between two planes. So I hope you understood like this theoretical part. And let's go to the task itself. We need to find the cosine of the angle between the planes that contains the faces SAC and ABC. So let's start with plane ABC. Firstly, we will write coordinates of points which we are given. So A has coordinates -1, 0, 1. B has coordinates 3, 2, 0. C has coordinates 1, 3, 2. And we have our wonderful formula, and we will just use it to get the equation of the plane and then to get the coordinates of the normal vector. So what we do? We take the first coordinate of the first point, so it's like x1, and we put it into the matrix. So we will write x minus 1. We take the second coordinate of the first point, and it will be y1. And we will write here, yeah, s. We will write here y minus, and y1 is equal to 0, so we'll just write 0. The next coordinate, 1, we will write that minus 1. And then we will take the coordinates of the second point. And according to the formula, we need to subtract the coordinates of the first point from the coordinates of the second one. So the coordinate of the second point is 3. And the coordinate of the first point is -1. So we write 3 minus -1. The coordinate of the second point here, it is 2. And the coordinate of the first point is 0. So we just write 2 minus 0. Then z2 in our case is equal to 0 and z1 is equal to 1. So it is 0 minus 1. The next thing is x3 minus x1. So what is it? x3, it is here, and x1 is -1. And it is 1 minus -1. y3 minus y1. It is 3 minus 0. 3 minus 0. z3 minus z1. It is 2 minus 1. And the determinant of this matrix is equal to 0. So we just need to simplify it now. I'll scroll down. And firstly, we get rid of all these minuses and brackets. So here it is just x plus 1, y, z minus 1, or 2 minus 1, 2, 3, 1. That's great. We just need to simplify this matrix, write it in a different form. We don't forget that here we have plus sign, minus sign, plus sign. So firstly, it is x plus 1 multiplied by, so you remember that we just, so let me take another color. So maybe this will be better. So we just cross out the first row and the first column, and we need to take this matrix. So we'll change it back. It is 2 minus, so it is multiplied by 1, so we just write 2 minus 1 multiplied by 3. And close the brackets. So the next element is with minus y, because we have minus here. So we multiply it by, so we cross out the second column and the first row, and our matrix is these numbers and these numbers, so which are highlighted with the green color are the numbers that we need to multiply and subtract. So in this case, it is 4 multiplied by 1, so just 4 minus, again, minus 1 multiplied by 2. And just close the brackets. Our next element will be with plus sign. It is z minus 1. So again, I'll take another color. So we cross out the third column and the first row. And our numbers are this, this, and this. So we multiply it by 4 multiplied by 3. So it is here minus 2 multiplied by 2. They are here. And close the brackets. So now we just need to simplify this, and we will get something like x plus 1 multiplied by, here we will get 2 plus 3, it will be 5, so we don't need bracket here, and minus y multiplied by, so you have to be careful because we have like lots of minuses. Here we will get 4 minus 2 4 plus 2, yeah, because we just have here plus 2, and it will be equal to 6, so I'll write it before y, and finally we have z minus 1 multiplied by 12 minus 4, it will be 8. So, very good. Now we need just to open the brackets. So it will be 5x plus 5 minus 6y plus 8z minus 8z. Oh, just 8. Sorry. Well, and we know that all this will be equal to 0. So actually, we can simplify it even more, and we will get 5x minus 6y plus 8z minus 3 is equal to 0. So I'll just scroll up, and you see that we have got this equation on the plate. And these numbers before x, y, and z are the coordinates of the normal vector that we need. So I'll take another color. So what coordinates do we need? This, minus 6, and 8. So we can now write that the coordinates of the normal vector of the plane ABC are 5 minus 6 and 8. And just for understanding, we can, if we put this number here it will be an equation of the plane. But for the normal vector, we just need only these three coordinates. And that's good. So, we have found the normal vector to the plane ABC, and we have one more plane, which is SAC. So the coordinates of it are, so for S we have 2, 3, 5. For A we have -1, 0, 1. And for C we have 1, 3, 2. So I'll again paste the formulas. And if you want, you can pause this video and try to compute the coordinates of the vector by yourself, like we did with the previous plane. And so, yes, and if you want to just check your answers, now we will do it. So, yes, here again we have 3 points, 3 coordinates, and we just put the coordinates into the matrix. X minus x1, x1 will be 2, so here we get x minus 2, here we get y minus 3, because the second coordinate is 3, then z minus 5, because this coordinate is 5. Now let's do the same with the second row. So x2 minus x1, it will be -1 minus 2. y2 minus y1, it will be 0 minus 3. Here, 0 minus 3. z2 minus z1, it will be 1 minus 5. 1 minus 5. And the last row, x3 minus x1, it will be 1 minus 2. Yes, because this is x3 and this is x1. y3 minus y1, it will be 3 minus 3, because here we have 3 and here again 3. And z3 minus z1 is 2 minus 5. Yes. And just simplifying it, x minus 2, y minus 3, z minus 5. Here just minus 3, minus 3, minus 4, minus 1, 0, minus 3. So then let's simplify it. Again, here we have plus, minus, plus. So first element is x minus 2. So we'll look on this matrix because we cross out the first row and the first column. And here we have minus 3 multiplied by minus 3. Take minus 3 multiplied by minus 3. Minus 4 here multiplied by 0. The next element, minus y minus 3. Don't forget about this minus. So we again cross out the second column and the first row and look on these 4 numbers only. So here we have minus 3 multiplied by minus 3. Yes, like this number, minus minus 4 multiplied by minus 1. So this yellow number and this yellow number. Close the brackets. And the third element will be z minus 5. It will be with plus sign because here we have plus. Open the brackets. It will be. So I can show the numbers we're working with. This. So we have, again, minus 3 multiplied by 0. Minus 3 multiplied by 0. Minus 3 multiplied by minus 1. And close the brackets. We just simplified. Here we have 9 and here we have 0, so we just have 9 multiplied by x minus 2. So here we again have 9 plus it will be 5 because it's 9 minus 4, 5, y minus 3. Here we have 0 and here we have plus 3. Oh, sorry, here we have minus 3 actually. Yeah, because at first we have here 3 and then we have minus here, so it will be minus 3 multiplied by z minus 5. So we just simplified even more, open all brackets, 9x plus 3 minus 18 minus 5y plus 15 minus 3z plus 15. So, and z will be equal to 0. So as you remember, we need just take the coefficients, the numbers which are written before x, y, and z. And in our case, yes, here it is, minus 5. And in our case, it will be the coordinates of the normal vector. So we can write that the normal vector to the plane SAC will have coordinates 9, -5, -3. So we got the coordinates of the second vector, which we needed. So I'll write here the coordinates we got from the previous step. So the vector to the plane ABC had coordinates 5, -6, 8. So, and now we just compute the cosine between these two vectors. So cosine of between these two vectors will be equal to firstly we multiply their coordinates and sum them up. It will be 5 multiplied by 9 plus -6 multiplied by -5 plus 8 multiplied by -3, and here we will have a square root of their squared coordinate. So we take 5 to the second power plus -6 to the second power plus 8 to the second power, 9 to the second power in the coordinates of the first vector, plus -5 in the second power, plus -3 in the second power. We just need to simplify it. It will be 45 plus 30 minus 24. In the bottom we will have square root from 125 and 115. Here we will have 51. Actually, if we simplify it and multiply it by the square root of 115, we will get this answer. So that's the answer to the part A of the second part. So that's the answer. And let's go to the next task, which is part B. So speaking about the part B, where we have to find an equation of the plane SAC, we can go back to our part A, and actually we did find the equation when we were finding the coordinate of the vector. So here is our equation. We just need to somehow simplify it, and it will look like 9x minus 5y minus 3z and plus 12. So it will be the equation of S A C.